Brian isn't with us today, so it's just here. But I have a guest. My guest is Richard Apodaca. Did I say that right? Should have
You did,
practiced that.
yes.
Okay, great. And so welcome to the hottest show on the blockchain and your #1 guide to the cryptocurrency revolution. So Rich, can you introduce yourself?
Sure. My name's Rich Apodaca, and I've been interested in Bitcoin since the middle of 2011. I got interested in it as a result of reading some things online, and managed to get in right at the top of a bubble that had been forming, and decided that, wow, decided that I really didn't know what I was doing, and lost a little bit of money as a result of making some mistakes. But I'm mainly interested in Bitcoin as a software developer. And I have, for the last few months, been writing a book, collecting my experiences with Bitcoin, what I learned about it, and hopefully that can help other people in similar situations to where I was.
Okay, great. So what was your first experience to Bitcoin? How were you introduced?
Yeah, so right around mid-2011, I noticed some references to this thing called Bitcoin on an online forum called Hacker News. It's kind of like Reddit. People post stories and discuss them. And I had read a couple of stories about Bitcoin and thought it was intriguing, but wasn't really interested in it because I had heard about other attempts to make private currencies that didn't go so well. It seemed like an impossible problem to solve, and so I wasn't really too interested in it. So eventually, I saw.
You were aware of cryptocurrencies before Bitcoin, or there was
no
none.
Other attempts to create private currencies.
Okay.
So back in the early '90s. The internet clearly needed a way for people to send value across the network, and credit cards evolved as a solution to that problem, but they weren't the first thing that a lot of people looked at. A lot of people looked at, or some people looked at ways to do this that were more like private currencies, and so Bitcoin wasn't the first attempt to create a value transmission system over the internet. The problem, of course, as is obvious in hindsight, was that these attempts were centralized. They were easy to shut down, to attack, and when I first saw Bitcoin, I didn't fully appreciate how decentralization really changes the game for something like a payment system or a currency or a value transmission system.
Yeah, that's interesting because all the centralized versions of these private currencies were shut down by the government, right?
Yeah, they were either shut down or they failed for other reasons. Sometimes it was lack of interest, but I think what really did them in was that the problems with processing credit cards over the internet started to become solved. So browsers started to implement cryptography in a better way, and that made the secure transmission of credit card numbers possible. Practices started to get put in place where websites that allowed websites to securely handle more or less securely handled the credit card data. The system became good enough so that people could use it with some confidence. And so I think that's really what started to do the idea and more. I mean, part of it was a failure of the systems themselves. Part of it was a lack of interest, I think, and the availability of something that seemed to work better.
So do you see Bitcoin overtaking these other systems?
Well, I mean, I think credit cards already overtook the payment systems that I'm talking about in the early days of the internet. So it's really, credit cards have, it's interesting. So credit cards have sort of entered the public mind as the only way, and therefore the only legitimate way to transfer value over the internet. And one of the things that I really like about Bitcoin, and I find extremely interesting, is how it turns that idea on its head and really questions the fundamental premise of the idea. So reading the white paper, it's pretty obvious that Satoshi had this problem in mind when he created Bitcoin. He had the problems of credit card payments in mind. He realized that credit cards were the de facto way to transmit value, and just asked the simple question: is there another way to do this? And if there is, how can it help solve some of the problems that credit cards have?
Great. So, tell us about your book. What's the title? Is it and how is it different than the other books that are coming out? Like the most popular one that comes to mind is Andreas Antonopoulos. His book, I forget what it's called, but
Mastering Bitcoin is his book.
Mastering Bitcoin, yeah, and yeah. So how is it different from that book, and will it be open source?
Yeah. So the title of the book, working title, but probably the final title, is Decoding Bitcoin. Okay. And the premise of the book is really a couple of things, but mainly the idea that using Bitcoin is not like using a mature technology. So, for example, you often hear the argument that it should be as easy to use Bitcoin as driving a car. You don't need an extensive background knowledge of the internal combustion engine, how the differential works, and how the transmission works to just get in a car and start driving. In fact, most people don't have that. However, cars are mature technologies. Bitcoin is not a mature technology. And what that means is that the individual user is exposed to the guts of the system often. They're exposed to things that work in unexpected ways, and it can cause problems. So the first owners of cars were not really viewed by a lot of people as that fortunate, because they spent a lot of time fixing their cars, to be honest. These things broke down a lot. There wasn't really a good understanding of how you make a reliable piece of machinery like this that's used by everybody. And so you really had to know a lot about a car to use the early cars that came out. Same thing with the personal computer. You had to know a lot about the personal computer in order to use a personal computer. Sometimes you even had to know how to program a personal computer before you could even do anything interesting with it. And so I see Bitcoin as being in a very similar place as these other technologies in their early stages. They expose the user to a lot of potential trouble that the user doesn't necessarily know they're about to get into. And so the book is really a recognition that this is where we're at with Bitcoin. And it's an attempt to create an information source that is detailed enough for an ordinary user to understand. My target audience is someone who has completed high school math, high school algebra in particular. If you've done that, then it turns out you can actually understand Bitcoin at a very fundamental level. The problem that I saw with existing documentation, though, was that you saw two different kinds. The first kind you saw was highly technical, highly accurate, highly detailed descriptions of the internal workings of Bitcoin, really written from the perspective of an expert in either cryptography or networking or some related technical field. Then the other side of it was documentation written at a very high level, often inaccurate, in an attempt to convey the information to users and prospective users, but introducing inaccuracies. And sometimes these inaccuracies will actually cause you problems if you follow them to their natural conclusion. And so I wanted to have a book or when I was learning about this, I wanted to have a book that didn't treat me as if I wasn't capable of knowing the information, but also didn't assume that I knew everything there was with respect to the background going into it. So the book that I'm writing is actually the book that I wanted to have when I was learning about Bitcoin.
Great. So what has the process been like writing a book about such a complex topic?
It's been challenging, very rewarding, and difficult. So one of the things that I found was when I sat down to write the book, I actually didn't know what I needed to know in order to finish the book. So in the process of writing the book, I've actually been learning the things that I didn't know before. So you know, a good example of that is a working system for dealing with Bitcoin savings. So when I first started writing the book, I was using a system based on paper wallets. And as I started to write the book and think from the perspective of a reader and sort of outline my process for how the paper wallets worked, I started to run into problems. And I thought to myself, hey, wait a minute, can I really recommend this procedure to someone based on these problems that I've seen? And I can't, you know, I came up with the conclusion, no, I can't. I have to come up with a better system. And so,
what are the problems with paper wallets?
Yeah, so paper wallets, I like paper wallets, I still do, but they have a hidden gotcha that kind of goes with them. So paper wallets are very easy to set up, and they're intuitive. You can understand what's going on to a certain extent. You go to a website, maybe bitaddress.org, and you create a paper wallet. You print it out on your printer. You create a transaction that sends funds to this paper wallet, and bam, they're there. You can look on the blockchain. You can keep tabs on it. Everything seems okay. The problem with paper wallets comes when you try to spend from a paper wallet. At least that's one of the problems. But this is the most obvious problem that hit me as I was starting to describe this system.
Because that's all I use for. That's all I really trust to use because I'm always sort of paranoid that my computer's compromised and I don't trust third parties. So the bulk of my bitcoins, which isn't very much, I keep on a paper wallet. So it's. Yeah, I need to be aware of these sort of pitfalls you run into.
Yeah, so as long as you're just putting funds onto a paper wallet, things are more or less okay. The problem comes when you try to spend, and to spend from a paper wallet, you need to sign a transaction, and to sign that transaction, you need a private key, of course. And the problem with the way that most wallets are set up, at least in their default state, and the way that they're customarily used, is that the computer that signs a transaction is connected to the network and the internet. And what that means is that it gives an opportunity for an attacker to use the network to steal a private key. And there are many different ways that this can happen, unfortunately. And the problem with doing this is that the number of ways to securely spend from a paper wallet are actually not that many. And it turns out that to create the paper wallet in the first place, you need to be aware of this network-based attack threat. And so it turns out that to securely create and spend from a paper wallet, you have to do almost as much work as it takes to do a what's called a cold storage method, where you do an offline signing, and maybe we can get into that a little bit later on in the episode, or maybe in a later episode. But anyway, what I found as I was writing the book and describing my system for spending from paper wallets is that the amount of work that I had to do to do it securely was not that much greater than just using an offline storage and signing method. And so that's the method that I decided to adopt for the book. That's the method that I'm describing in the book. And the reason has to do mainly with this is viewed as essentially the gold standard way to do long-term storage of funds, and it's not that much work than simply doing paper wallets if you do them securely.
So for Bitcoin to become ubiquitous, do you feel that everyone has to know these procedures for securing their wallet, or do you think they'll come to rely on third parties, or will it be like something like with a car? I mean, everybody knows how to change their oil, and do the little things, maybe change their brake pads, but.
Well,
And
actually, you'd be
if we
surprised. A
don't,
lot
we
of
all
people.
call our friend who does, so, which would be you.
Yeah, well, a lot of people don't know how to do these things. A lot of people have never changed an oil filter. A lot of people have never even opened up the hood of their car themselves to look at anything. Cars are actually getting more complicated, and so it's harder and harder to do anything meaningful other than maybe change the oil and brake pads. But getting back to your question, actually, I think Bitcoin is at a stage in its development right now that people do need to be aware. They need to at least be aware of the major pitfalls, and they need to be aware of things that they can do to protect themselves against these pitfalls. It's sometimes a risk to one person isn't really a big risk to another. And a perfect example of this is, imagine you have a user who's storing 100 millibits on a paper wallet, and this represents 0.01% of his net worth or her net worth. Then you've got another user who's storing a full Bitcoin on a paper wallet, and this is this person's entire life savings. Okay, which of those two people is going to be most interested in secure storage and the ability to locate the funds and spend them in the future? It's going to be the one who has the most skin in the game. So, and these questions apply to all of the questions around Bitcoin at a technical level, and how much do people really need to know how it works in order to use it.
Yeah. So yeah.
So getting back to the. Oh, go ahead.
For example, yeah, and also another big, more difficult thing in Bitcoin is staying anonymous, which isn't important to everyone, but maybe it should be. How does the average person how are they supposed to keep their anonymity?
Yeah, I know it's a crazy word.
I
How
hate
are they
that word.
supposed to do it? Yes, this is so. What I didn't realize, and what I think a lot of people starting out, and maybe even people who have done this for a little bit, what you don't realize getting into Bitcoin is that the privacy model of Bitcoin is diametrically opposed to the privacy model of the traditional banking system. So, and Satoshi describes this very elegantly in the white paper, probably better than I could ever do it. But the crux of the problem is that the traditional banking system relies on trusted gatekeepers to secure private information. And private information in this case should, in principle, cover all of the transactions that you make and all of your personal details, your phone number, your name, your address, your credit history, these things. And what these trusted gatekeepers do is selectively release your private information to partners and other organizations they work with to allow them to do what needs to be done, to process your payment. Maybe it's an outside credit rating agency that they need to work with. But the idea is that the full scope of your transactions is not on display for the public. Now, that's the ideal, but as we've seen repeatedly, for example, the recent Target hack, the problems at Chase with the big release of private information, as we see increasingly, this private information that we're entrusting to these gatekeepers isn't really secure. And really, we don't have very good ideas of how to secure this information. Bitcoin's privacy model is based on a totally different idea, and that is all of your transactions are public, and they're put on this data structure called the blockchain that sits out, a copy of which sits on every miner. So there's thousands of copies of the blockchain in existence, maybe tens of thousands, maybe up to 100,000, who knows. But there are many copies of the blockchain in existence, and every transaction that you make goes into the blockchain. And that sounds that may not sound like a problem, especially if you're first starting out, or you really haven't considered privacy to be something that you need to worry about as an individual. The problem comes in when you merge this privacy model. Oh, let me back up. So Bitcoin's privacy model is based on the blockchain. Every transaction is public, but it's also based on another idea, and that is pseudonymity. And what that means is that users interact with each other on the network through pseudonyms. It's kind of like you create an email address that doesn't necessarily reflect you personally. So you might have an email address just to receive spam for signing up to various services. That's a kind of pseudonym. And then your real email address is more closely linked to your personal identity. In fact, you may actually have your actual name in your email address. And you want that because you want people to know who they're writing to and who they're receiving email from. So there are different situations where you want more privacy or less privacy depending on what you're trying to do. Now what Bitcoin says is that this should be up to the user. And so every user can claim or generate for themselves a pseudonym. And they'll use this pseudonym to receive payments and to make payments. And the only record of an identity that the blockchain contains is a record of this pseudonym that you create, that your business partners and other counterparties in transactions create. As long as that's the only information about you on the blockchain, then or available to, let's say, an outside investigator or a third party, as long as that's the only information available, then your privacy is actually pretty well kept.
Obviously, that works. If somebody can still steal, $4 million or whatever it is on Bitstamp, and that person got away, as far as we know.
It's pretty effective. It's pretty effective. Now, the thing to keep in mind, though, is that Bitcoin, it's possible to use Bitcoin as a self-contained ecosystem or economy, if you will. All you do is receive payments in Bitcoin, and all you do is make payments in Bitcoin. That is possible, and there are people who are starting to do that. There's been a few media stories about people doing this. The problem is that we're not at a sufficiently advanced stage with this experiment that it really is possible for everyone to do that and continue to survive. Rents need to be paid, mortgages need to be paid, paychecks need to be received, and there are solutions for merging these kinds of activities with Bitcoin, but they're in their early stages, and so most Bitcoin users are not using them really prevalently. The problem is that you have to have an on-ramp into the Bitcoin economy. Someone has to sell you that first Bitcoin. Just like in 2011 when I started out, I needed to buy Bitcoin from a guy who I didn't know, but I needed to give him dollars in exchange for him giving me the Bitcoin, and that's the case now as well. Mining is very, very much out of reach for just about everybody, and so that's not really an option. Now, the problem with buying Bitcoin is that, and this is a problem with any transaction in Bitcoin, your counterparty knows things about you that other people, casual observers, investigators looking at the blockchain, they don't know, they can't know. So, for example, let's say over this Hangout right now, we were going to make a Bitcoin payment, right?
All right.
You know exactly who I am, and I know exactly who you are. So I ask you for your address, and you give it to me, and I make the payment. So at that point, some private information has changed hands, right? So I can link your personal identity to the address that you just gave me. And a couple of weeks from now, I can go and I can see what you ended up doing with that payment. Did it sit there? Is it still available? Did you merge it with other payments to the same address? Did you pay anybody? If you paid anybody, do I recognize any of the addresses that you paid? And the same thing with me as well. You know where the payment is coming from. You can see the address that made the payment to you, and you can go and look at my transaction history as well. Now this only happens because we each know each other's, let's say, legal names, or our full names, and maybe we have some other information.
Mm-hmm. Yeah. Well, this isn't my real name, so.
Okay,
Yeah.
you're using a pseudonym.
Yeah, of course. Of course, you got to in the Bitcoin space. Yeah, but as soon as you send a payment to another address, that could be one of your addresses, or it could be someone else's addresses. Sometimes I worry about that when I sell Bitcoin on localbitcoins.com or with Mycelium wallet. Sometimes I wonder, like, what's this guy going to do with this Bitcoin, and is it going to be linked back to me? I think Local Bitcoins has some safeguards against that, and maybe Mycelium does too. But it's something that goes through your mind, definitely.
It does, and the reason being that making a transaction with somebody puts the record of that transaction on the blockchain, and you're right. One of the reasons to think about financial privacy and Bitcoin is that things could potentially be traced to you inaccurately, or things could be traced to you that it's simply nobody's business knowing. Either way, the two parties of a transaction have information that outside observers don't have. They have the knowledge of a couple of things. First of all, it could be as simple as knowing exactly when the transaction was made. So when a transaction posts to the blockchain, you never really know exactly when the transaction was made. And that can be useful information when combined with other sources. Another thing is the identity, of course. We already mentioned the identity of the payer, but potentially also the IP address of the person that's sending you a payment, for example. Let's say you have a website and it accepts Bitcoin payments, and you're logging IP addresses, and that allows you to potentially link the IP address of the person who paid you with an IP with a Bitcoin address. So there's lots of considerations there. There's lots of things to think about, and it all depends on the relationship that you feel that you have to this idea of financial privacy. A lot of people consider financial privacy something that only applies to people with something to hide. But at the end of the day, we've all got something to hide, and that's not bad. That's a fact of life. So I don't think very many people would want their entire history of credit card transactions to appear on a public ledger somewhere, or their future history of credit card transactions. There's, for one thing, even if you don't care about whether or not people know, there are various kinds of attacks that can be carried out against you with that information. So, for example, if somebody knows that you've got a lot of money, that makes you a target potentially. And so privacy actually covers that kind of case as well, where you're trying to not make it you're trying to avoid people learning what your net worth is. You're trying to avoid people learning where your next payment goes. These are the kinds of privacy features that every financial system has, and Bitcoin does, provided that you know the implications of pseudonymity as the privacy model.
Great. Yeah. Great. So, what other things are you planning to cover in your book that you feel that are important points of Bitcoin?
So I had a very difficult time understanding Bitcoin at a fundamental level because of one major piece of the puzzle that I had forgotten. So, and it has to do with this idea of a mental model. So most people, when they use a personal computer, they have a mental model for how files work on the computer. And modern operating systems give them that model. You have folders, and you put files into the folders, and you can move folders and files. You can delete files by putting them into the recycle bin. which isn't really deleting the file. You can always get it. And then once you empty the recycle bin, then it's really gone. But the thing is, this is just a mental model, and a computer doesn't actually work that way. It works on a totally different set of principles, but the mental model allows you to use the system in a way that you're going to cause yourself the minimum amount of trouble. So it's a bridge. It's an interface between how the machine has to do its job and between how the machine does its job and how you want to do your job. And so what I was missing with Bitcoin is a mental model for how it works. And I had seen many descriptions of it, and it was always compared to something. And then when I tried to follow that description through, it started to break down. And I saw places where it could actually cause problems. And what I came up with, the missing piece of the puzzle was actually in the title of Satoshi's white paper. Bitcoin is an electronic cash system. And I read that many times and I glossed over it because I thought, well, electronic cash just means you can send payments electronically, right? That's all it is. But actually, electronic cash has very specific meaning and a long history that goes with it. And Satoshi, in his paper, didn't really spend time explaining that. This was information that he assumed the reader had already in their head, and so he didn't bother to cover it in great detail. The idea of electronic cash is actually very, very simple. Bitcoin is a system where, well, let's go back. So what is cash? Cash is often a piece of paper or a piece of metal that we agree that has some value. So, for example, a $1 bill. We can meet in person, and you might have an item that's valued at something under a $1 bill, and I have a $1 bill in my pocket. I pull out the $1 bill and I give it to you, and you give me the item, and that's how we make the payment. What doesn't occur to a lot of people is that you can actually make electronic tokens that do the same thing, that have the same function. In other words, a token that can be sent to somebody irreversibly, and which that person can then use to pay someone else, and so on and so on. This is the fundamental idea, I feel, behind Bitcoin, is this idea of electronic cash. And understanding this idea helps you not only keep yourself out of trouble with respect to security, privacy, generally not losing your money, but also in understanding what Bitcoin could be used for and why it's such a versatile system for doing all kinds of financial transactions that aren't cash payments.
I think the first thing that pops into to people's heads when they hear about an online currency or electronic cash is they think of their files on their computer and how you can just copy them and make more. And so immediately it seems silly. Like when I first heard about Bitcoin, it sounded like a total scam, of course. And yeah, and the way people explained it. I found the information that was out there at the time definitely confused me, threw me for a loop. One example is how they explain mining as doing math problems. I thought people were literally solving algebra problems for their for random people online or something like that. So yeah, there's definitely a long way to go as far as explaining. But yeah, so yeah, sorry, just continue on the electronic cash.
Well, yeah, mining is actually a good example. So a lot of explanations of Bitcoin start with mining, and I feel that that's the worst possible place to start, because miners are solving a very specific problem related to electronic cash, and without understanding electronic cash first, talking about miners is a very baffling process. It really does seem like a scam because it doesn't make sense what the miners are doing, why the miners are getting paid. And so it's a perfect example of lack of understanding of the idea of electronic cash can lead you to a conclusion that really isn't accurate. So getting back to this idea of electronic cash, and you brought up the really excellent example of files on a computer, right? So imagine that a file on your computer was the equivalent of the digital equivalent of this $1 bill that we were, trading for that I was giving you as a value payment. So, and people know intuitively that through experience that you can make infinite number of copies of that file, exact identical copies, indistinguishable from the original. That's the nature of digital media. And they're absolutely right. And so Bitcoin has to solve this problem of people attempting to spend this digital token in multiple places. And this is what's called the double spending problem. It could be multiple payments made with the same digital token, but it has the name of double spending. And so that's what the Bitcoin network, that's the problem that the Bitcoin network is solving. And that's the problem that Satoshi set out to solve when he wanted to create Bitcoin, was how do we solve this double spending problem? Now, the traditional solution to this problem, and the solution that was attempted in other electronic cash systems before Bitcoin, was to have a centralized authority. And the centralized authority would verify whether or not the token or coin, it's also called, that you were about to spend, the digital token representing the value, whether or not that had already been spent somewhere else. And if it had, your request was rejected. But if it hadn't, then your request was logged, your token was invalidated, and the mint issued you a new token, a new digital token that came directly from the mint. It bore something called a digital signature, which we can talk about later. But a digital signature simply is a way to prove the authenticity of a piece of digital data. And because the token came directly from the mint, signed from the mint, another person would accept it as payment, because the mint would never allow its own tokens to be double spent. And so this is the solution. This was the state of the art when Bitcoin was envisioned and created, is you had a centralized mint that solved the double spending problem. And the problem with the centralized mints, of course, is that they're vulnerable to a lot of different scenarios. They can go under, they can become financially insolvent and just go belly up. They can be attacked. There's a big pot of gold at the end of the rainbow for anybody who wants to break into one of these systems and compromise it. Regulators have a very easy time of either shutting the system down altogether or crippling it in such a way that it doesn't become useful. And so there's lots of problems with this centralized solution to double spending. And what Bitcoin does is it solves the problem using a decentralized system and this new invention called the blockchain.
Yeah.
And so what the miners are doing is they are preventing the double spending of these digital tokens.
Yeah. And yeah, so that is one of the most difficult things. People, when you tell them about Bitcoin and mining, is everyone's like, "Oh, I want to mine. That sounds awesome. Just making money with your computer," which is totally not accurate anymore, but at one time was. But do you even attempt to explain the mining process in any detail when telling someone about Bitcoin, or do you just kind of save it for more technically savvy individuals?
Well, if they're still with me when I'm talking about electronic cash, if they're still with me up to that point, then I think that's a good point to start talking about mining. It doesn't really make a whole lot of sense before, but the problem is that that's what people hear about. That's what brings a lot of people to Bitcoin, is this idea that you can run a program that will actually make you money. It is a fairly bizarre and exciting idea at the same time, and it appeals to a lot of people. But when you start off with mining, the whole process just doesn't make sense at all. And I feel you really have to start with this idea of electronic cash, not just to understand mining, but to understand Bitcoin as a whole. And it's the step that I really ignored in the very beginning, and it cost me a lot of time and a lot of effort to figure out what it was that I was missing that kept bringing me back to not understanding what was going on. See, my mental model, going back to mental model, my mental model for how Bitcoin worked was kind of like how a credit card worked. So when you make a credit card payment, it seems like you're moving a specific amount of money from point A to point B. And that makes sense. That's what we deal with all the time. Or someone moves a specific amount of money from, let's say, your company into your bank account. And that is not how Bitcoin works. You're not moving a specific amount of money to cover the cost of the transaction. You're moving a token from one person's ownership to another. And so this has huge implications, not just for understanding mining, but for understanding, like I say, what Bitcoin could be used for, but also for keeping yourself out of trouble.
So you're saying it's not the tokens themselves that are moving; it's the ownership that is a better mental model. Okay.
Yeah. So so the tokens are actually being the ownership of the token is being reassigned to another pseudonym. It's being locked. It's being locked in a way that only the person that claims that pseudonym, or that claims that pseudonym, can actually unlock. So it's as if one analogy might be that we take the dollar bill payment and we put it into a lockbox that only you can unlock.
Yeah.
And you have the option to keep the dollar bill in that lockbox for as long as you want, or you can unlock it and give the token to somebody else. But I can't ever get into that lockbox and remove the token. Just imagine that there's something like a slit, that allows me to drop dollar bills in, but doesn't allow me to pull any kind of dollar bills out.
Yeah. Yeah, I mean, I think that's great. So I think it's good that people like you are out there creating these new, or promoting these better mental models for understanding Bitcoin, and I want to challenge you. I want you to can you give us a better mental model for understanding mining, which is one of the most difficult things to wrap your head around. It took me quite a while.
Yeah. Let's see.
I know it's challenging.
So, yeah. Well, okay. Provided that you understand that miners are solving this double spending problem, there's a number of solutions that might come to mind as to how to do it. Like I said, the mint is one way to do it. So actually, the first chapter in my book is a discussion of this very topic. The first section in the book is a broad overview that deals with all of the components of the Bitcoin system, but doesn't deal in great detail with any one of them. So I stopped just short of where I hope most people's eyes would start to glaze over. Although that's a moving target, I guess, for different people. But what I'm trying to do is not blast you with tons of information, but give you an overview of how the entire system works, so that in the later parts of the book where it talks about these systems in detail, you actually know what the terms are that I'm talking about, and we don't have to dive into a lot of detail. So let's take this idea of the mint. So the mint is verifying every transaction before it happens, right? We can come up with another model for the mint. The mint is something where I submit a digital token, and the mint checks to see whether or not this token has already been spent, and if it has, then it rejects my requested payment to the other user. But if the token has not been spent, then it accepts the payment. So it's kind of like a check light, right? Or a gate. If my transaction passes and I'm not trying to double spend, the gate's open and I'm good to go. But if my token has been double spent, then the gate's shut and the user is not going to receive the payment, and the user will know about this. Okay. So this is one way that you can solve the problem of double spending. Now, what Bitcoin does is says, look, that mint is a big source of trouble, right? Although it solves a double spending problem, it introduces an even bigger problem, which is systemic risk. If that mint goes down, the entire system grinds to a halt. And the problem with that is if you're holding the tokens and you can't trade the tokens are essentially useless and valueless. And so this would be a catastrophe. Your entire holdings the value of the holdings would evaporate overnight. And so this is correctly recognized as a serious limitation of the system. So what happens if we say we're not going to have just one mint, but we're going to have two mints? And that way, if one mint goes down or gets compromised or attacked or shut down by regulators, we have the other mint. And so no matter what, we've got a fallback. And not only that, but we're going to put the other mint in a different legal jurisdiction, a different country, maybe on the opposite side of the planet. If you want to get crazy, let's say an asteroid or some natural disaster, strikes the location. Yeah. So now you've got two mints, and that's great. So you've got two mints, but now you've got a fundamental problem, right? You solved one problem by getting rid of the central point of failure, but now you've got another problem in that the mints have to communicate with each other. Because if I send my attempted transaction to, let's say, mint A, and you're only paying attention to mint B, it looks like the payment hasn't gone through. So the mints have to have a way to communicate the transactions that are coming in, the payments that are being made. They have to have kind of a private network or a way to move that information back and forth between the two of them. And so you can create a system. You can draw a schematic of how this would work. Okay, when I send my transaction to mint A, it's going to relay that transaction to mint B, and then you'll be able to see the transaction, and you'll be able to know that the payment that I'm giving you hasn't been double spent. And that's all well and good, but the problem that starts to happen is what happens if mint B goes down? Okay, so we've got this system, or let's say we start to have a very slow network connection between mint A and mint B, or let's say we start to have errors. Some kind of network problem happens, and
so it's just a temporary problem then, right?
It could be, or it could be a more permanent problem. It's not really. I mean, it could be either way.
Okay.
So, if this happens, though, we've traded one problem for another. We've traded the problem of double spending with the problem that now we've got to keep these two mints in constant communication with each other. And the problem only gets worse if we started to add, let's say, mint C, mint D, mint E. Maybe we want to have 100 mints just to be certain that no matter what happens to this system, no matter what governments try to take it down, no matter who tries to attack it, we've always got a mint that can process payments. And you start to get this very complex network of, well, let's see, every mint has to be able to talk to every other mint to make sure that transactions, spread out over the whole network. And as you start to go down that road, you realize that you've got a mess. You've created a mess of network spaghetti that doesn't work right. Any delay in, let's say, receiving an acknowledgement back from one of the mints causes the whole system to start to freeze up. And so what Bitcoin does is it has a network protocol that allows the mints to effectively talk to each other, to effectively spread these transactions out over the entire network, and avoid this problem of gridlock that can happen if any one of them starts to experience problems. And that's essentially what miners are doing. And I prefer the term auditor to miner, because it really reflects what the main job of the miner is, which is to audit transactions.
Yeah.
Miners are doing something else, and we can talk about that if you don't have any questions about that.
Yeah. No. Yeah.
What we just talked
that
about.
was beautifully said. Yeah. Go on. So the mining, where does that come into this?
Yeah. So let's say we've got this network protocol, and everybody's happy with the way that it works. Anybody can connect to any particular mint, and they can receive transactions that were sent to any other mint, and the transactions verify the same way regardless of which mint that you connect to. It's a beautiful system. The only problem that you have is, well, where do these tokens come from in the first place? We haven't we haven't solved that problem, and it's actually a pretty fundamental problem, because it has to be whatever solution that you implement has to be one that's fair, that is easily verified, that doesn't introduce any bias into the system, and has some mechanism to regulate the rate at which new money enters the stock of money. And it has to solve all of these problems. And it turns out that auditors or miners are actually in an ideal position to solve it. First of all, because it takes effort, it takes resources to run a mint or an auditor or a miner, however you want to term it. To run a system that protects the network in this way takes resources, and so automatically there's a need to somehow compensate the people who are doing this work, who are providing these resources to the network. And so why not pay them for it? Well, how can you pay them? You can pay them by allowing them to receive the new tokens that get created. And so that's the basis of the mining reward, also known as block subsidy. But this is the source of the payment that the miners receive. So in exchange for protecting the network from double spending, they're receiving a payment of brand new tokens that the network allows them to have.
So back to your mint analogy. So you have mint A, B, C, D, E. So what makes it so that these mints can trust each other? So how do they know they don't? There's not a bad mint in the mix trying to screw them up.
Well, see, this is the thing. They can't.
Yeah.
They have to assume that any mint that they talk to is actually trying to deceive them, trying to rip them off, trying to rip somebody else off. They have to assume that that's the way that things work. And so the protocol, the system that they use to communicate with each other, has to tolerate that kind of thing happening on the network. And that's the source. That's the reason that Bitcoin has certain other features in it that you might have heard about. For example, blocks and the blockchain. It's a mechanism by which trust gets eliminated from the equation, at least trust in the intent or capabilities of one of the other mints. What happens is, wow, this is interesting to try to explain it verbally.
Right.
So what we're trying to do is we're trying to create a kind of proof, a kind of mathematical proof that says to anybody who receives it that that this message from a mint is actually authentic, that it wasn't forged, and that it actually represents a valid communication on the network. And so the way that the mints, the mechanism that the mints use to communicate this information is packaged and bundled into a digital element called a block.
Yeah.
And the block contains a collection of all of the transactions that have happened within a particular time period, and secures them in a way such that with mathematics that it's impossible to forge the relationship of this block to the relationship of previous blocks. So I don't know.
Okay.
I don't know how far down the rabbit hole you want to go.
Bravo. No, that was beautiful. I think people will enjoy that. They need to go there. So great. So yeah, I guess maybe we'll stop there, and I encourage our listeners to keep going down that and try to better your understanding and get Decoding Bitcoin when it comes out. What do you have a ETA on that?
Well, like I said, I've been working on it for the last several months. It's actually gone through a complete rewrite. I got to a point where I realized that I was on the totally wrong path, talking about exactly the wrong things, and started fresh. So it's been several months. I expect that it will take another couple of months before it's actually ready. What I hope to do is I have a mailing list, and I plan on sharing chapters in draft form as they come out, give people a chance to review it, to ask questions, to make sure that I'm on the right track. And I've started doing that.
Okay, great. And tell me about Bitsuma. What are you trying to do with that project?
Yeah, so Bitsuma.com is a website which is mainly a blog at this point. And the idea is that there are topics in Bitcoin that don't really lend themselves well to inclusion in the book that I'm writing. They might be too specific or too narrow to fit into a book in a manageable size. And so that's what Bitsuma so far is about. So if you go to Bitsuma.com, you'll see articles on, for example, change addresses, which is a huge problem that a lot of new Bitcoin users face. Understanding why they're there, despite the fact that they don't seem to be doing anything useful, and how to keep yourself out of trouble, how to prevent yourself from losing money, essentially, with change addresses. There's another one that talks about compiling Bitcoin Core yourself from source code. There are other articles that talk about buying Bitcoin. There's an article on buying Bitcoin through local Bitcoins, which is a type of liquidity provider, a way to buy Bitcoin that requires very little personal information to be revealed, and which a lot of people don't realize you can actually pay for your order with cash at a bank teller. And so the article talks about how to do that. There's another one that talks about paper wallets, how to make them securely, how to spend from them. So various types of things like that are on Bitsuma.com. It doesn't get updated nearly as often as I want to, but hopefully as the book starts to tail off and get ready, more articles will be appearing there. But it's got about, I don't know, 10, maybe 15 articles there right now.
Okay, great, awesome. So one last thing. Did Mark Karpelès start the Silk Road?
I have no idea.
Yeah.
It is interesting, though, to think about creating a service like an online marketplace that accepts payments in Bitcoin. By itself, that marketplace isn't going to be very useful without a way for users to exchange their local currencies into Bitcoin. So you really can't have one without the other. The exchange by itself isn't that useful if you can't buy things, and the marketplace itself isn't that useful if you can't obtain the currency. So, but I don't think that necessarily implicates anybody in anything. It's just interesting to.
There's a really interesting correlation between the time when the Silk Road Bitcoins were seized and like soon after that, we had the incredible spike in Mount Gox, which was kind of mysterious and sort of like unfounded. There was people saying it was Chinese adoption, but I never really saw any really good evidence for that. But so the price increased, and all of a sudden, Mark had lost everyone's bitcoins. So it's pretty interesting, that correlation right there. Like, could those seized bitcoins be Mark's bitcoins? I don't know. It doesn't. It seems kind of odd.
Well, yeah,
That's
the
my
way that I read,
tinfoil hat conspiracy. Could be right. So go on.
that's an explanation. Another one is that at the time that we had that last spike, fiat withdrawals were essentially unavailable, and so you could add money to the system, but you couldn't. You could add local currency to the system, but you couldn't take local currency out. And that has only one. The price has only one way to go when that's the case. So I don't know, but your explanation also. I mean, there's so many ways to explain what happened, and I don't even know if we're ever going to get to the bottom of what really happened there. But fascinating story.
Yeah, I mean, it's definitely, you cannot write this stuff. It's too good.
Yeah.
I mean, a lot of people joke about the amount of popcorn you need when you're in the Bitcoin world, because you're always watching really interesting things go down. From the
Definitely.
inside, yeah, it's definitely interesting. So, great. So I just want to thank you for coming on the show, Rich. You are the very first guest of the Chain Gang. So I hope I can have you on again, because you have a very good way of explaining these topics, and I think people will really value that. So looking forward to your book, and everyone else, check out Bitzuma, bitzuma.com, and stay tuned for next week's episode of the Chain Gang. All right. Thanks, Rich.
Okay. Thanks, Keith.
All right.